Final year of electrical engineering. Let's go. If you haven't watched so already, go watch my first and my second year breakdowns in 5 minutes. Let's go. First, we start off with embedded systems in C++. This was a super heavy module with an introduction to the C++ programming language, but it wasn't really like there was an expectation that you know C++ already. Object-oriented programming was introduced. Input-output, call by reference, call by value, dynamic memory allocation using the new keyword, function overloading, meaning, hey, we can use the plus sign for whatever we want. Pointers, don't forget pointers. And then we looked at, more solutions for embedded environments using stuff like polling, pooling, polling, interrupts, concurrency, cool, stuff like this. We also looked at more in-depth stuff like volatile pointers, data structures and classes for hardware solutions or hardware interfaces. We went quite deep and looked at device drivers and hardware control, and we used the STM32 a lot. All my courseworks were with an STM32F3. That's it from the coding side. But we also had design. We were introduced to UML, Unified Modeling Language. We looked at the use case, the class, the sequence, and the state diagram. We would go from user specification all the way down to all the diagrams and then to code. And we also learned about design patterns. I went quite deep and I started looking into singleton, the mediator, all of these design patterns that we use in software engineering. I also studied state space control. And if you're enjoying this video, hit a thumbs up, comment down below. State space control is pretty much normal control, but in the state space world. What does it mean? Everything's pretty much in a matrix. So what do we do? Everything is in MATLAB. As always, we're looking at transfer function representations. We're looking at things like linearization over here. We look at designing and implementing these problems in control theory in state space, which is with these fancy matrices. And this is where it gets really interesting. We look at things called observability and controllability, which pretty much first asks us the question, what is the controllability of this? Can we even control this, or is this just going to blow up every single time? And observability is how much can we observe? How can we look at the states of a system without actually knowing it, but just inferring it from other sensors, other sources of signals and information? Really, really cool. We looked at LQR and LQG control. And another big one was we looked at Kalman filters, and that's pretty much everything. Really cool module. We also had the dreaded engineering management. What did this look like? We looked at project management principles, agile, waterfall, all this management theory. We looked at ways of like planning and different stages of project management. We then got into accounting, and this was financial accounting, profit and losses, balance sheets, cash flows, all of the really boring but useful stuff. We also had management accounting. What is this? This is something like break-even analysis, elements of cost, marginal and standard costs, overheads, electricity bills for your business, something like this, and other types of costing like ABC and target costing. I don't know what that meant. We also had project evaluation stuff. These are things like ROI, payback, NPV, and there was also quite a big part about like the law, the legal stuff. It was called like industrial legislation. This looked at health and safety, contract law, specifically in the UK, sale of goods, employment, IP rights, tort of negligence, and product safety and liability, aka what happens when the car blows up, whose fault is it? Another thing we also did look at is quality, stuff like tools, TQM, ISO 9000, SPC, SDC, and Six Sigma. Next, I had a really funky module. It was called machine learning for IoT devices, but it was more like machine learning inference for IoT devices. This was a funky module. At the start, we were introduced to neural networks. Then we got straight into running deep learning models on resource constraint environments, which are pretty much STM32s. Yeah, I used specifically an STM32F7 in this module because it had a lot of these cool like machine learning features. Here we focused on performance, memory usage, precision, and power consumption of machine learning models when they are ran. We looked at like the trade-offs, positives, negatives of using different models on these embedded devices and seeing if it's worth it, is it not worth it. And yeah, then we pretty much just presented like all our results that we ran. There was no exam here. We had another module with embedded stuff. So this was my third embedded module, which was called Cybersecurity for Embedded Systems. This was really cool, and it also used the STM32F7 microcontroller. Here we looked at the AES and the XTA and the SHA-256 algorithms, which are used for cryptography. We looked at, encryption, decryption, the more computer scientific theory behind this, how a hash is calculated, your private key, your public key, all of this type of stuff. And then we looked at the cybersecurity or the crypto features of the STM32F7, which was using stuff like true RNG, which is quite cool. This was like grabbing the random electronic noise from the circuit, from the actual hardware, and converting that to a true random number that then can be used as a hash for any sort of encryption that you want to do. We also looked at firmware signatures. This is to make sure that when you are updating your firmware, it's safe and there's a way to like sign it. It's quite interesting. Have a look. And that was pretty much it. Next, microwave comms. This was a huge module. Microwave communications. We start off with antennas. We looked at array antennas for wireless communications. We had a very deep look into Maxwell's equations, now from a way bigger application standpoint. And you haven't watched already, go watch my second video in this series where this was introduced to me via advanced electromagnetism. Next, we looked at the plane wave propagation and polarization, stuff that's actually taught quite early on in physics, but comes in. And when it comes in hot here. We looked at transmission lines again. We also looked at cables. This was quite odd to me, but we looked at coaxial and microstrip lines, how the coaxial cable actually looks like inside. We then looked at VSWR. And you may know what VSWR is if you've used a Smith chart, the scary looking Smith chart, very related to things. You can use a Smith chart to calculate VSDR. We looked at reflection and transmission coefficients. We looked at Poynting's theorem, and we also were introduced to waveguiding systems. We had another look, a refresher on the scattering matrix and scattering parameters, and these were used to do stuff in microwave circuit design, looking at things like couplers, circulators, power dividers, and each one of these had their own unique scattering matrix. We looked at measurement systems. We also had a really funky subtopic called signal flow graphs, which is like an application to graph theory for microwave circuits. And we then also used some CAD for microwave circuit design. And that was the module, and it was crazy. That's everything from the studied modules. And you obviously had the biggest thing, the final year project, the engineering thesis, the thing we're all waiting for. And I did my thesis in the application of graph neural networks to simulate the airway flow in the lungs, which is pretty much a computational biology project applying graph neural networks to have a great way to try and model the lungs, which usually are used with CFD techniques. It was really, really cool. And this is what really got me into like computational biology and machine learning. I really strongly recommend you do something not related to electrical engineering, just to see what else there is. But if you love it, then obviously do something in electrical engineering. But yeah, that's everything. Thank you very much for watching this video. If you enjoyed it, if you found it helpful, if you found it insightful, comment down below. Tell me what you guys think. What do you think of my curriculum as a whole? Was it good? Was it similar? Was it not similar? Yeah, hit a like, subscribe. Thank you very much. Bye-bye.